We are building the Sports Heroes project from the YByte Python curriculum available at www.ybyte.in. In the previous video, we saw the union operation between two sets, um, which basically gave us either or type of scenario. Let's say we are interested in a different question. Uh, who are the people who have won both Wimbledon and French Open? Clearly, they appear in the union set also, but let's say we wanted only these people to be represented. Again, Venn diagram makes it very clear. There is a list of there's a set of players who have won, let's say Wimbledon, set of players who have won French Open. What we are after is the overlap between these, because these people have won both Wimbledon and French Open. And the way we do it is using this ampersand operator. Quite simple actually. Just one point I want to make, that the player may in fact have won both of these tournaments more than once. So it's like another level of classification. But then they will still be represented only once in the intersection set, which makes a lot of sense, right? I will get to my code over here. Previously in the comparative analysis, I was doing only, let's say, either or. Now I'll just copy this entire piece of code, and I'll just say, well, let me, put place it again over here. So what I'll do is that I will, put this, let's say, along with the, say here. So I just go and say, look, winner of both. This will be an ampersand operator. That is what is called an intersection. So I'll just call both is intersection between winner set one and here I will just go and make it, let's say, winners say both are, this set should be changed to winner both. And these are obviously say winner both. When I now run this piece of code, when I, let's say, do this, notice my analysis.dat, I expect it to have more lines at the end, and indeed it does. So it turns out that there are 8, and again, reflect on the achievement that these people are demonstrating. Only 8 individuals who have won both French Open and Wimbledon since 1968. I mean, this is just absolutely incredible. Uh, just shows how hard it is to do this achievement, right? And these individuals are, of course, listed here because that set contains, what we are looking at. Again, we can take an example. Let's say I have a set which is 1, 2, 3. I have another set which is B, which is say, 3, 4, 5. When I do an intersection between these two, if I were to do C is, let's say, A and B, well, that is going to be only 3 because 3 is the only item that is common to both the sets. Now you may wonder what happens if, let's say, my set B was something else completely, let's say 7, 8, 9. Clearly, when I do a union between these two, if I, let's say, were to do C is A union B, I will end up with, let's say, 1, 2, 3, 7, 8, 9 because both the sets have just been combined. However, even though there was no overlap between them, but on the other hand, if I were to do C is A and B, in fact, C will be an empty set because there is no overlap between them. So, think about it. We have taken Wimbledon and French Open. We did expect some amount of overlap. But if you took, let's say, two different sports completely, perhaps there'll be no overlap, right? And again, depending on how the set has been defined, there may be an overlap, there may not be an overlap. Intersection is telling you that, look, we can find what the overlaps are, and that's why this is quite interesting. Now, just like earlier, I can run this operation a bit differently. I can go and say, look, A is this, B is this. I can create a C which is A dot inter, say intersection, say B, and that, well, obviously is an empty set. But the point is, instead of using this ampersand, I could have used a slightly longer method of doing it, but I actually prefer the ampersand because it's just so much more compact. And you will see later on that this will this is kind of somewhat similar to what is called an AND gate later on when we learn about the bitwise operator. Once again, I hope that applying these ideas to something which is very real, something that we are very connected to, makes them come alive. And that is what we are trying to do here. That is how we learn Python at YByte. Do look at our website www.ybyte.in because you will find that there are many, many, many such activities of this sort. Take care. Thank you so much. Bye bye.